Hey there, ladies and gentlemen. In this lesson, we are going to be discussing how to simplify radical expressions and essentially reduce them down to a more user-friendly format. We're going to be doing two methods for simplifying radicals. If at any point you need to pause and write something down, or if you want to pause a video and try something before I get to it, by all means, please feel free to do so. So the first method we're going to do is called prime factorization. And what this is going to mean is we're going to factor radicals down into their prime factor components. Just as a refresher, prime numbers are numbers that can divide by nothing other than 1 and themselves. So 2, 3, 5, 7, so on and so on. With the exception of 2, prime numbers will always be odd. Because if we have an even number, you could divide by 2, and therefore it's no longer prime. So we're going to go ahead and factor these out. What I like to do is as I factor, as soon as I hit a prime number, I'm going to circle it. And then at the very end, once everything is circled as far as prime factors are concerned, I'm going to look for pairs of primes. And that's going to help me with my factorization. So without further ado, let's factor 20. I need to start off by choosing any two numbers that could multiply to be 20. It does not matter which two numbers I choose. I'll go with 4 and 5. 5 is prime, so I'm going to circle it. 4 is not, so I have to keep going. To get 4, I could do 2 and 2. Those are both prime, so I'll circle them. From here, I'm going to look for pairs. Well, I've got a pair of 2's. If numbers can get paired up, they're going to get pulled to the outside of the radical. So I'll have a 2 getting pulled to the outside of a radical. Left inside is anything that did not get paired up. Well, in this case, it's just the 5. The 5 did not get paired up. So we've now reduced the square root of 20, rad 20, is the same as saying 2 rad 5. Let's do the same thing with 48. 48, any two factors that go into 48. Let me start off with 4 and then 12. Neither of these are prime, so I'll keep going. 4 breaks down into 2 and 2. And looking ahead, there's a pair right there. 12 can break down into 6 and 2. Ooh, I got another prime with the 2. And then 6 can break down into 3 and 2. And those are both prime. So once I've kind of worked my factor trees all the way down until I can't factor anymore, I'm going to circle those because we have prime values. I should make note, from right here, if you factor 12 with a 3 and a 4, you're still going to wind up with the same circled numbers resulting from it, 2 2's and a 3. All right, so now we pair things up. I've got a pair of 2's over here. I've got a pair of 2's right here. And I've got a lonesome 3, so the 3 is going to be stuck inside the radical. So I've got a 2 and then another 2. So each 2 comes from having a pair of 2's. And then trapped underneath the radical was the 3, the lonesome 3. So if I were to multiply those, let's see, 2 times 2 is 4. So the square root of 48 actually reduces down to 4 rad 3. All right, last one. We have 5 rad 18. This 5 over here isn't really going to affect our factorization, so I'm just going to ignore that for the time being, but I'll keep it in mind for my final answer. So I'm just going to send the 5 all the way down here when all is said and done. All right, so we factor 18. Any two numbers that multiply to 18. Let's go 2 times 9, and 2 is prime. 9 can go down to 3 and 3. Both of those are prime. So now I'm looking for pairs. I've got a pair of 3's. So since I have a pair of numbers, that value, in this case 3, will get pulled to the outside. And then I have the leftover 2, so that gets trapped underneath the radical. So the 2 has to stay underneath. So now to simplify and make things look pretty, I've got 5 times 3 is 15. 15 rad 2 will be our simplified answer. So that's the first method of doing these. If you're comfortable with this method, by all means, keep doing it. This method is pretty user-friendly. The only downside is it does tend to take up a lot of space on the paper. The second method, you're going to have to think a little bit harder, but it doesn't take up as much room. So the second method uses something called perfect squares. Now, perfect squares are any number that you can take the square root of to get a clean result. So the square root of 4 is 2. Not 2-point stuff, it's 2, exactly 2. The square root of 49 is 7. So the fact that we have these perfect squares is going to come into play. So when we break these things down, our goal is to try to find the largest perfect square number that would go into one of these values here. So let's start off with 98. I want to find the largest number from this list, and this list would go on indefinitely. I just ran out of paper space. If I kind of work backwards, that'll help me figure out the biggest one. Beyond this would be 81. 81 does not go into 98 cleanly. 64 doesn't work. 49 would work. So 98 is really the same thing as saying 49 times 2. So instead of thinking of this as the square root of 98, I'm going to think of this as the square root of 49 times 2, and I've kind of unsimplified that. And what that's going to allow me to do is think of this as the square root of 49 times the square root of 2. And from here, I know the square root of 49 is just 7. So final answer is going to be 7 rad 2. Next up, we have 24. Again, I'm trying to find the biggest number from this list that would go into 24. So the biggest number that might possibly work is going to be 16. 24 divided by 16 is not going to work out well. 9 wouldn't work. 4 goes into 24. So 24 is really the same as saying 4 times 6. So I could think of this as the square root of 4 times 6, but in reality, each one of those could be underneath their own individual radical. And we know the square root of 4 is just 2. So this turns into 2 rad 6. Final answer, we're done. Last and final one, 3 rad 98s. Well, as we discussed before, we already know that 98 is going to turn into a 7 rad 2, and we learned that from the example directly above. The only difference now is we have the 3 that came along for the ride. So we have 3 times 7 rad 2, that's going to give us 21 rad 2. And we're done. That's it, that's all. If we're stuck on anything, please do not hesitate to send me an email.